Hi, my name is Daniel Kwan and this is Bishop Montgomery High School Math Tutoring Club. We're located in Torrance Boulevard right next to Red Island Beach. Today we're going to talk about or learn about how to find the exact sum of a given series in an AP Calculus BC test. So, in order to do this, we have to know if it is harmonic series, if it is geometric series, or like which test we have to use. So I'll give you guys some few examples of test problems. So in test, it will always include, obviously, sigma n equal to, so n equal to something means I'll just go with 1. The starting number will be, we'll be plugging in 1. So let's see. Let's go with easy one. 4 over 3n. So 4 over 3n. If we rewrite this, it will be, so I will plug in a few numbers. So starting from 1, it will be, because it's series, it will keep going and going, right? So it will be 1, 2, 3, 4, 5, 6, like that. So let's see. 1. Oh, first of all, again, for this, I made a mistake. For this, I'll just show you. Sorry about that. So it'll be 4 over 3 for 1 plus, because we start with 1, and now it's 2 plus 3 over 4. I mean 4 over 3, right? So the thing I said about is I made a mistake. This is because when we look at it, this multiplies by 4 over 3, right? That means times 4 over 3, 4 over 3 times 4 over 3. That means this is a geometric series. And last video, we talked about if geometric series r is less than 1, it converges. However, when you look at it, r is greater than 1. So that means it diverges. So because the limit goes to infinity, this series diverges. So I'll give you a new example. I'm lazy, I'll just go with 3 over 4 now. So what you can do is this. Like we did, 3 over 4 n, which is 1, right? I have a tissue in my hand. Plus 3 over 4, 2 plus 3 over 4, 3 like that. So this is n, and n increases by 1 and it goes to infinity. So let's do this. Because you cannot do this infinite times and solve problems, let's use a trick. We know that this is a r, right? This inside number is r, and it's multiplied by this number each time, right? So r is what? Yes, 3 over 4. Now, what's a? Last video I talked about a. A is the first term of this series. What's first term? It's 3 over 4. So, and again, last video I talked about how to solve the geometric series, sum of the geometric series, which is a over 1 minus r. A over 1 minus r. So let's plug it in. 3 over 4 minus 1 minus 3 over 4, which is 3 over 4 over 1 over 4, which is cancels out and becomes 3. So for this type of question, oh, that square or circle is weird. Sorry. So this is the answer. Let me check my work. 3 over 4, a is 3 over 4, 1 minus r. So 1 minus r is 1/4, right? And then divides, cancels out, and becomes 3. So for this, the sum of this series is 3. So let's move on to other examples. So another example can be, let me think. So it'll be 2 and 3n. Let's go with that. 2n, 3n. You can think, it's separated. How can we do this? We did this in algebra 2, I think, or pre-calculus, I'm not sure, but for this, we can change this equation to 1. I'll just change this equation here to 2 over 3 n. If you're curious, put it into calculation. This is how we change this. Over 3, it's like this. So, again, now this example is exactly same as the last one. So it'll be, again, if I write this, 2 over 3, 1 plus 2 over 3, 2 plus right? So what's r? Again, 2 over 3, because it's multiplied by 2 over 3 each time. And we can see r is what? Less than 1, so it converges, so it has a limit, so we can solve for it. And sometimes in AP Calculus MCQ test, it asks, one of the multiple choice is no, or the series diverges. However, we have proved that this converges because r is less than 1, so we can keep going. What's a? 2 over 3. Now, let's plug it in. 1 minus r. Oops. A over 1 minus r. 2 over 3, 1 minus 2/3, which is 2 over 3, 1/3, again cancels out and becomes 2. Right? So for this series, it goes to 2. Now, let's go. So, a little bit harder one will be, I'll go with M2, I like the bottom ones. So 2n over 3n plus 1. How should we do this? Again, you can think, before it was 2n over 3n. However, now it's 2n over 3n plus 1. So, this is another algebra. I will simplify it right here. I was like, how should I write it? So n plus 1, right? So we can divide this by 3 to the power of 1 times 3n. Do you get that? The base number is same, so I'll write this one in n bigger. So it's 2n over 3 to the power of 1 times 3 to the power of n. So because base is the same, we can add. So I just divide this into 2 terms. 3 times 3n. Now, we can do this easily. Equals to 1/3 to n over 3n. Oops. Like that. Like that. So now, this was exactly the same as last time because I added n plus 1, it'll be 3. If I added n plus 1 to the top, then it will be 2 because again it will be 2n plus 1, 2 times 2n. So this will be 2. However, because I put the plus 1 at the bottom and it's 3n plus 1, it will be 1/3. So let's do this. R. What's R? If you get confused, it is like one of the definition or like the rule of the sigma notation. You can take this term 1/3 out of the series. So you can just look at this 2/3. So R is 2/3. And another trick, you can just think, oh, what's in the parentheses by power of n? That will be always the R because this is multiplied every time, not this. So what's A? You have to really be careful. So n starts from 1, right? So you plug in 1, it'll be 2/3. Do not put A as 2/3 like last time because 1/3 is added. So it'll be 1 over 2 over 9. Multiply. This will be our first term, okay? So, again now, 1 over 2, oh, sorry, my mistake. A over 1 minus R, which is equal to 2/9 over 1 minus 2/3 equal to 2/9. And I was like, what? Which is equal to, if we change that, it will be canceling out 3 and it equals to 2/3. So for this series, it will be approaching, or it has a limit of 2/3. And I will now introduce and for next video, I will introduce a ratio test. Thank you for watching and I hope this video was helpful.